the podcast where the real world meets the digital world as we explore the intersection of spatial computing and AI. Let's welcome our host, Andrew Ballard. Over to you, AB.
Well, g'day. Welcome to episode 3 of Spatial. Yes, we're back and we are down by one, a different one this week. We are minus Violet, but we are plus William. William, g'day. Welcome back. How are you faring?
Hi, thanks very much. I'm feeling much better. Appreciate the short break to recover.
Well done. Great to have you back with us. Mirek, g'day. How are you? You looking nice and relaxed? You've got the Mexican sombrero in the background. We really do need to convert from audio to a visual format soon. So
yeah. But in actuality, we are snowed in here and it's very cold. So I'm just brightening up the mood a little bit.
Dreaming of Mexico. And Helena, close to the beach, enjoying it, or the family's getting some good beach time in?
They're all.
Excellent. Brilliant. Yeah. Well, let's jump straight into News of the Week with a segment we call Fast Five.
Fast Five.
Mirek, over to you first. Homework is in, submitted. Top marks to you. Gold star. What do you have for us this week?
So this week I'd like to mention an initiative that's coming out of Google and 33 robotics labs around the world. It's called RTX, and it stands for Robotic Transformer X. And the big idea is that with the advancements in large language models and generative AI, you might expect similar kind of behavior from robots, and that it would just translate, this intelligence would just translate to robotics and robotic manipulation. But that's not really the case, because a large language model typically is based off large amount of data scraped off the internet, and it's pretty much a compressor or autocorrect on steroids. So it's predicting the next most likely word, expression, whatever. And it goes the same with generative AI that can generate visuals or even music. Same kind of principle. This doesn't really work with robots, because robots need to manipulate their own body. They need to have this image of their own configuration somewhere, so they like humans do have their own internal image of our bodies. But what you typically do with a robot and a neural net is that you have to train robotic configuration specific hardware for each specific task. Say pick and place, or assemble something, fold a t-shirt, make me eggs, or whatever. And you typically have to even have to train the robot for a particular environment. So this is really specific, really lot of work that goes into each specific thing that you then see the robot to perform. So this initiative aims to change that by putting together lots and lots of data sets. They say they have about 1 million different robot trials doing individual tasks for 22 different robot types or robot body configurations. Mostly this is robotic arms in different configurations. And they've included about 500 different skills, such as, fold a t-shirt, open a door, call an elevator, these kind of things. And the aim of this initiative is to create this higher level of abstraction for a robot to sort of be able to operate across many different body configurations. And this is then combined with what you might, this is actually the second step they're working on, but this is being combined with this sort of neocortex-like intelligence that LLM might provide. So say you want the robot to pick an apple and place it in between a banana and a helicopter, right? So the robot needs to know what a helicopter is, what a banana is, what between means. And this kind of high-level intelligence comes from a language model and this data scraped off the internet. But then it's combined with these motor skills that come from this multi-body kind of model that's capable of performing these tasks across many different hardware configurations. And surprisingly enough, there are 34 robotic labs involved in this initiative, and 5 of them recently did a test where they compared their own in-house best effort, the best solution to certain tasks. And they compared it with this new approach, with slightly more universal approach that takes into account different body types. Say, like a human, when you pick a electric drill or you get on a bike, your mental image of your own body sort of extends to the tool or vehicle, and we're able to work with that, but robots can't. So this sort of approach makes this much more closer to how human brain operates, and the results are surprisingly positive. They say that. Finding it in my notes here. Sorry, that the multi-robot data improve Google's own robot capability by a factor of 3, and this is compared to their former best effort. Might be a combination of algorithms or neural nets, but this kind of abstraction seems to be really helpful in improving generalized robots' capabilities, and combined with then this higher level of reasoning, produces really striking results.
That's amazing. That's phenomenal. Not only the fact that they are using the physical robot setups of everyone's labs and then to prove that, but the fact that they've gone back to a general approach and that's able to beat their highly trained bespoke and compete. That's definitely one to watch. Huge thanks for that, Mirek. Awesome. William, over to you. I think CES was on your radar the last couple of days. What have you got for us?
Yeah, I think as part of that event, one of the really interesting releases, I think, was this device called the Rabbit R1. It's a personal assistant. It's hard to describe. It's a personal assistant. It's a small orange device. It was manufactured in collaboration with a design group called Teenage Engineering. That design firm is well known for their audio devices. And they manufacture and they design and manufacture really finely designed audio devices and other computing equipment. In fact, my PC is a small form factor PC of Teenage Engineering design.
Oof, nice.
They're quite well regarded, quite expensive. Well, the computer case wasn't expensive, but their audio devices can be. And this particular assistant is quite an interesting thing. The startup, Rabbit, found at rabbit.tech, starts their keynote by talking about the constraints and challenges around large language models. LLMs in particular can understand intent, they say, but are not particularly good at completing actions. And so in the AI world, as we all know, there's this growing notion of creating an AI agent. So creating an entity that is powered by AI that can perform tasks on your behalf. And you can sort of endow an agent with either capabilities and or permissions to perform those tasks. And so the way that this company sets up their kind of agent design is by saying first that we need models that are tuned for this notion of going and performing actions. And they call their invention a large action model. And then they wrap that large action model into an operating system. That operating system is designed with a particular performance goal of being quite responsive to you. If you've interacted with ChatGPT or other models, depending on network traffic and whatnot, those responses can take some time to come back to you. And so their argument is having a dedicated operating system, in addition to this dedicated large action model, can create quite fast response times, but also then when it's in this pocket companion, they call it, this Rabbit R1 device, you can take it with you and it can start to perform actions on your behalf. Things like playing a song off of Spotify. But then they extend that a bit further. The device itself has a camera, it has what they call an analog scroll wheel, and then a push-to-talk button. And with that vision camera, they've embedded a number of capabilities that we've seen demonstrated by other companies like Google from Google Lens or the Gemini model or other OpenAI-based solutions where you can sort of take the camera, point it at your refrigerator, and ask it to, make you a dish that's low in calories, and so forth. And in addition to that, there's ways to interact with the device outside of the device, so by email, and also there are capabilities that let you sort of teach the R1 new skills. So they go through a demo of generating imagery through Midjourney and showing you the process of training it that way. And so they try to position this as an assistant that's complementary to your phone. It doesn't replace the phone, but it starts to get to that place where you can just ask it, I want to go on a trip to London. Can you organize this for me? And then it goes through a series of steps in that workflow to arrange the trip for you. That particular use case I'm quite interested in. I hate planning trips. It's so tedious to go from app to app, price shopping, finding the right flight. So hopefully there's some actual real value here.
With the form factor being so minimalistic, it is just, I think, a screen, a camera, and a scroll wheel, although I'm going to have to call it a fidget wheel rather than a scroll wheel. So it definitely is from the teenage design world. How would you think that trust is embodied in this kind of device? If it does plan the entire trip for you, does it speak it out? How do you know it's researched all the gamut? How do you get that, confidence level that this interface is doing all the things for you, quote unquote, perfectly?
Yeah, right now the demo that they show in text on the screen will display the trip that it has come up for you. The demo that the CEO does also gives it feedback and says, this looks really complicated, or it looks as if there's a lot of activity. Can you design a simpler trip for me? And I think it brings up an interesting question that you're asking, because with these assistants, what are the expectations that we should actually have of them? And I think that there's a kind of interesting dichotomy there when we have certain sets of expectations that perhaps come more from Hollywood and movies than it does from technical reality, where we think that not only is it a machine, that the machine that is powerful and reasonable mathematically and logically, but perhaps it has some level of infallibility to it. But large language models, I think, have demonstrated that if you train models on human data, and you train models in a way that is analogous to, in some ways, to the way that humans learn, that they come up with very human flaws, or they demonstrate quite human flaws. They seem to lack a kind of self-awareness, though. There have been studies done that say that while they can correct their mistakes, they're not necessarily aware that they've made a mistake until you prompt it. And so with a device like this, I think it requires some calibration of expectation somewhat. Maybe it's treating it more like a human travel assistant, where you can give it feedback, but you sort of trust them enough to take care of those details. Maybe a travel assistant that you haven't worked with before.
Worked with a few times. Yeah. So effort number one is going to be with kid gloves, but as you grow to understand it, and it does show that trust is warranted, you can kind of give it more and more taskings. Thanks for that, William.
No problem.
Helena, for you, Fast Five.
Yeah, sorry, I forgot to put mine in before. So you'll hear about it for the first time now. I want to talk about a piece of software I tried for the first time this week called Opus Clip. You might know it. It's a AI video editing software. So essentially, you just plonk in whatever video you have, like from a video podcast or whatever. And what it does is it picks out the best kind of snippets for micro clips. and pulls those out into its own little videos. So what even just a year ago was like a laborious manual task is now just pretty automated. So we've been doing this kind of micro clipping for clients for several years, and that was always something that just took so much time, because you have to look for the perfect little segments, you have to pull them out. Then another big workload was always getting the transcript and then making sure that the captions were all correct, because even using Adobe Premiere, a lot of the times it transcribed the speaker's words wrong. It would turn GIS into chorus or any other creative word.
Always the hard.
And so I was, it's pretty it was really difficult, even with the pro software. And now all of a sudden, all of these AI video clipping tools come out, and I was so surprised at how good they are. So it pulled out from a 34-minute video, it pulled out 8 or 10 clips. It didn't do a single error in transcribing what was being said, so it was 100% spot on, and the cuts that it took were really, really good. Plus, it gave me for each little clip a little summary of what's the key message here, and it turned that into a headline. So I ended up with 8 or 10 clips with a headline saying this is the key message, the perfect transcript, and the little kind of 50-second video which is perfect straight onto LinkedIn or something. And it kind of just made me think about the changing role of the specialist, I suppose. So and geospatial and everything, everyone's always kind of the specialist providing solutions, right? So there's always kind of the very generic terms that they use to describe themselves. But I think with the democratization of data and technology that is just happening so fast, and that goes for geospatial data and technology as well, the role of the specialist is changing. And what used to be a technical role, for instance, clipping videos in Adobe, is not something that just anyone can do. I mean, it's not a highly technical role, but also kind of creating maps, or all of these kind of, that used to be a profession where the profession was using data and tools to extract information. I don't know where that's heading because of this acceleration in these AI tools, and I think it's great. I think the democratization of all of this stuff is great, but I think it also means that we have to kind of reevaluate what our role then is as the operator of these technologies, and kind of perhaps how that whole workspace is changing. And I think it's really interesting that things that even just a year ago we thought, no, that's miles away, it's here now. And I'm just really fascinated by it. Just very keen to see how that evolves, especially in the spatial geospatial domain, because I mean that has always been a bottleneck in so many large companies. They're sitting on all this geospatial data. The analysis team is really, really small. The engineers need the data. The geologists need the data. Everyone needs the data. They've got one GIS person, and there's just a massive bottleneck there. So now with the democratization that's happening, everyone can start doing their own analyses, but they don't necessarily have the background to really fully kind of understand the nuance of what they're doing, I suppose. So we might have some issues creeping in, and how do we handle that, and how do we walk the balance between it becoming the domain of everyone and still having that specialist expertise. And that's kind of just what I've been pondering while being very fascinated and very thrilled that I can now create my own microclips. So
I've seen the tool in use. I saw it on your LinkedIn profile, I think either just in the last few hours or maybe it was yesterday, but it looks fantastic. But you're right, that would have been a massive task. It would have been an undertaking, and probably someone who, had to sit down and scan and then sync and then get the transcription right. To have that as the proverbial red button is phenomenal. It does mean we'll see more of that, but that's probably a good thing, because to take the highlights from video, you sort of need to have a way to scrub and raise the highlights. Even if there's, yes, probably a better highlight to the left or right of it, at least you're bringing something to the surface that is, that draw card. And yeah, it's now hopefully getting it easier to do. I think, the form factor is going to be huge in the next little bit. Thanks for bringing that to our attention. I think I want to try that too. For my Fast Five this week, I want to roll back a couple of months, but not too much. The last quarter of last year, there was a large model for image creation release called GigaGAN. Now, it's a GAN, which is one of the models where two models actually self-score themselves. So one model, the output of one, tied into the input of the next one, goes round and round. GANs are typically fairly focused. So most of our image to text and our image generation now is not in this mode. But I'm not too worried about the fact that this is a GAN. The bit that I'm most excited about is this middle section of this model is actually able to do super resolution. And super resolution to me is still just magic sauce. If you've ever watched any of the CSIs or any of the bad spy movies where they say, enhance, zoom in, and you just do the biggest facepalm because, how can 4 dots become a license plate from deep space? There's more money spent on the CGI in the movies than there is in any CSI division anywhere around the world. This one is obviously making stuff up, and that's a polite way of saying super resolution is not just inferring. When you're making, let's say, 4 pixels into 400, at some point in time, you're not just interpolating color values, you're actually infilling in some level of smartness. But this one's huge. It goes from an output of the image generator of 128 pixels square, which is, not even a fraction of a megapixel if you put that in camera terms, up to a 4K by 4K, so 16 megapixels, so 4,000 by 4,000 pixels. That means that every 1 pixel in the original image turns into roughly 1,000 pixels in the output image. And the results are stunning. It really is phenomenal how it really is like looking at a blurry image. You wake up first in the morning, or you haven't had your the coffee hasn't hit the bloodstream just yet, and you're seeing something that you can kind of vaguely make out. There might be a hair or a fold in someone's shirt or something like that. And suddenly when you do the super resolution, there's not just the fold or the hair, but there's levels of details that simply were not there, yet they were made up to a level that is believable. So my open question to the team that we'll probably tackle in the deep dive in a few minutes is, are these kind of models making stuff up just to satisfy us, the humans who are in the loop, and to say, yep, that was good, nope, that was bad, try again? Or do they have some level of semantic understanding of objects and depth and, how hair does look and how hair does fall over a shoulder, or how, scales on a turtle actually comes to fruition? Because it is using its resources of, I guess, backwards training. It probably started with the 4,000 by 4,000 images. They downsampled them down to the tiny ones and then reversed the process, said, right, best score for trying to get from small image to large image wins, go for a couple of billion years of CPU time. So it's my question, open question, which I think, we will tackle soon, is, by what level is this magic? By what level is this making stuff up? By what level is this starting to be the understandings of there's enough encoded within this model to actually understand going from 20 pixels to 2,000 pixels, it can actually make stuff up reliably. And by all means, the pictures there on the website are phenomenal, going from the tiniest to the largest files. It is just amazing how big a 4,000 by 4,000, I mean, most people's HD screens or 4K screens, it's bigger than, it's a square 4K screen. It's massive. So going from such a postage stamp to like a movie poster, just out of this world for someone like me who was playing with Photoshop back in the early 90s, when a 1 megapixel image would wipe out your computer. Alrighty, team, we might pause there. We'll take a quick break and we'll come back with Deep Dive.
Deep Dive.
Okay, welcome back. William, I'm going to hand it over to you a little bit, if that's all right. Apparently, you have just started your new lecture season on spatial AI. By the sound of it, this does feel like this is lecture number, well, we're getting a preview of a forthcoming lecture. Is that kind of correct?
Yes, that's right. Our first class was yesterday. Students seem interested. It's indeed a course called Spatial AI. It is being taught at the Graduate School of Architecture, Planning, and Preservation at Columbia University. And it's part of the computation sequence, but it's intended to kind of bridge this gap between modern artificial intelligence techniques, which, as we all know, are all the rage now, and the challenges that designers of space, particularly architects and urbanists, encounter in their practice. The probe and prompt for the students is, how can we research together ways of using large language models and multimodal models in a way that helps our spatial design propositions, helps us understand space, model space, and make decisions, not only for the space itself and perhaps the people that are constructing buildings and cities, but also for the inhabitants of those spaces eventually. And I think architectural design in particular is quite an interesting realm for this, because architects don't actually get a chance to design buildings with buildings. They design buildings with representations of the materials that go into buildings. And even one more step removed is the experience that the inhabitants of those buildings have. So there's almost a translation of 3 different media that we have to go through. And so it's an interesting area. The computation sequence in most architecture schools really focus on tools. They focus on building information modeling. There are some innovative tools like visual programming editors, one called Grasshopper that's quite popular. And but this course tries to take a slightly different approach. We're going to start off by asking 2 key critical questions. 1, what is space? And 2, what is artificial intelligence? And then can we work together to see how they can bolster each other? And so the lecture coming up is the What is Space lecture. It's been an interesting philosophical question for over 2,000 years, at least in Western thought. Everything from the ancient Greek concept of topos to the Japanese concept of tokoro and ma. There are architectural concepts of public and private, secular and sacred, inside, outside, and threshold, and even geographers' concepts like image space and place space. So part of our journey together to start is to unpack those concepts and then use large language models as an assistant in that investigation.
So what's the current state of a large language model to actually be able to do more than, the shorthand, which is a neat way to talk about a large language model, is a text calculator. Mirek said before, it can predict the next word, and when it does that reliably for so many tokens, for so many thousands of words, it looks like magic and it carries on. What is the state of large language models right now with being able to have any concept of depth, space, orientation? Coming back to the Fast Five, is it pseudo? Is it magic? Or are we starting to get those nuggets of truth coming through?
Yes, that is the core of the question, I think, that we're going to probe in the course. And what I think prompted those sorts of questions for me was what you're also hinting at. Large language models are remarkable for their sort of impression of a huge breadth of knowledge, and also mirroring, understanding what we're saying. Like when Google first became big, we all had to learn how to speak Google. We all had to learn about keywords and how to compose them. And there were certain things that you couldn't ask Google unless a website had already asked the question in the same way and had answered it. So and large language models now give us that ability. Like you can, especially when you're in a situation like, what is that movie that had this character where someone said this and the situation was like that, and like you couldn't quite remember it, and a question like that is really difficult with a search engine, but quite delightful to do with a large language model like ChatGPT. But then finally, it has this ability. Maybe I'll say, for the sake of argument, it seems to mimic or mirror the ability to reason. And so large language models are benchmarked on standardized tests, for example, like in the US, the law school admissions test. It has an analytical section where there are questions like, there are 5 people sitting around a table, and Joe doesn't like sitting next to Madeline, and Albert always likes sitting next to Cheryl. And so then you ask questions about different types of arrangements. And I think that actually starts to hint at this idea of using an LLM to reason about space. And so that's something that I think is really fascinating. And we saw some of those hints at it with the agility robotics example from 2 weeks ago, from episode 1. And so I guess I'm really curious about what other folks think about that sort of potential to reason about spatial configuration. Does it understand above, below, between, and so forth?
Yeah, Mirek, the link that you gave us, the robot brain being a generalist now, it is putting forward that it has the topics and the concepts of between, above, move X to Y. By all means, does that sort of have the same capability and the same option for growth in this early stage?
I think this is related, and I have more questions than answers, to be frank. But it seems like large language models can generate meaningful text even when there is no understanding of the subject, and inherently they are trained to please the human prompter, right? The human element. And I'm thinking like especially when it comes to 3D space that we evolved to live in. So we have really deep understanding of spatial concepts. Even there are interesting things that our brain does that many people aren't aware of, like the people who compete in all sorts of memory exercises, memorize, hundreds of digits of pi. They often, or most commonly, use technique called memory palaces, which means that you imagine a 3D space that you're familiar with, and you just place your clues in that space, and then you follow a path in that space, and then you just read it sequentially as you would be traversing that space. And this is really easy for us to do, but I would argue that a language model, as we see them today, has no concept of that. So it may generate something that to us seems like it makes sense. It's kind of like, yeah, this is what a human would say. But I'm imagining sort of a parallel example. Like imagine you're born blind and you've been reading your whole life about the best visual art that humans have produced. And you can describe Van Gogh's Starry Night with really excruciating detail, but you have no concept of how it feels or what it's about or what it's, how it came to be. So that's sort of where I'm sort of philosophically when thinking about these kind of technologies and how that translates to 3D space. If that makes any sense, it's, really vague and anyway, so when it comes to like actually implementing something that allows machines to understand the space around us, I think there need to be some sort of extra layers that provide this kind of capability and that can sort of help machine to sort of make sense of space. And maybe in like a computer game scenario, this is kind of closer than language model might be today. Maybe your NPC in few years down from here, may have really good spatial understanding of their own environment, and that sort of generates really interesting behaviors. There have been experiments with people hooking Minecraft to large language models, And I believe that that sense of space and what you can actually do with that space, and where's your resources, where's your danger, where's your friends, and that sort of defines how you navigate around that space and how you perceive it, and that maybe somehow builds some understanding of the space the way we perceive it. That's kind of how I think about it.
Yeah, I think one of the problems is that, it hasn't really even been unanimously sorted on a human level, so there's still so much human debate about place and space and what constitutes each. And, not only is there, literature in like English that goes back, centuries, it's the same in every other culture and every other language. And I think what large language models might be able to do is to help us bring a lot of that together. So I know, for instance, that there is a lot of German research into the space-place concept, but it's completely not ever brought into the English research of the space-place concept because it's simply not the same people who have understanding, of the language even to then investigate. And so I feel like there is probably a lot that has been a lot of different philosophical angles, a lot of different approaches across different languages that hasn't necessarily been brought together. So I think there's probably quite a lot of disparate reasoning going on and a lot of disparate definitions, and potentially, I've just done a quick chat GPT and asked it to tell me about like the different place concepts in different languages, and it actually has gone and looked into literature in other languages, and then I asked it to explain it to me in those other languages because I also speak German, so I understand, and it's given me a pretty accurate output on that. So it seems to be competent across all that kind of stuff. So I think what we can accelerate is, as humans, our understanding of the state of the art, so that we're not kind of when we're developing concepts and when we're kind of doing research, that we're not kind of reinventing the wheel of something that has been solved in a different discipline or in a different language, but that we really do now have access to the world's knowledge basically at our fingertips, and it's not subject to those same barriers. So I find that a really promising approach to then maybe getting some progress on the actual space-place definition before expecting the language model itself to kind of understand and teach robots to reason, In
my mind, it's been 12 months almost to the day since the GPT hit the mainstream public. Everyone started using it, and it was massive. Yes, it had a few years before that, but it was, this is the time where it's taken off in leaps and bounds. But already now, I think there's a move coming from one acronym to another, going from large language models, LLMs, to multimodal is sort of the approach of trying to fold in more of that spatial, more of that depth knowledge. I guess there's a general trend, which I don't know whether this acronym will survive, but general world models, GWMs, by adding more than just 2D images. And I mean, video reproduction is good, but it's kind of just a sequence of 2D images. Going into that depth perception plus the object recognition is a potential for large language models to add on that multimodal factor. I've seen fledgling ideas of those, and Mirek's link today was certainly another one in that step where it's got the ability to reason. But I guess coming back to large language models, I would be really keen to find out, William, what your thoughts are about how it can be extended, or even how you can prompt it to start to tease out those ideas of above, behind, go north, those kind of things.
Yeah, totally. And those are the kinds of experiments we want to run in the class. I think that, again, the analytic questions on some of the standardized tests really point to those opportunities. From an architectural perspective, I think it's an interesting profession because most of what you see in terms of spatial design are the outputs of the kind of artistic outputs of the architect. So the renderings, the models, the kind of creative sketches that happen early on in schematic design. But there's an awful lot of language that's written about buildings. There's the source material like building codes and zoning codes. Those are all written, aside from the diagrams that accompany most of the text. There is a specification that's written along with the building, and significant buildings, those specifications can be on the order of thousands or tens of thousands of pages of written documents about what materials are used, where are they positioned, and so on and so forth. And I think in a similar way, fiction writing describes space and place in very interesting ways. And so those are probably some of the source material that sort of introduce the opportunity to reason spatially with an LLM. But I think what we're all hinting at here as well is absolutely right. I think where the real experiments happen are when we enter that multimodal space where we can get something that is LLM-like interacting with something that is not necessarily written language. And so we ran one of these experiments in class yesterday where we have Mirek mentioned a gaming engine. We have a physics engine hooked up to GPT-4 through OpenAI's API. And you can ask it things like, add a cube to the space, add cubes to the space in a grid pattern, add some boxes that are twice as long as they are wide and drop them on the ground plane, things like that. And it works out of the box. The context prompt is very simple. It just says, you're an assistant that is helping me manage a space full of objects. And then there's a function you can add to that is a query function. So you can say, describe the space to me. And the gaming engine returns a list of objects, their sizes, and their centroids, their center points. And it can actually say, like, there's a cluster of boxes over here that seem randomly arranged, and then there's one over in the corner. So that's really fascinating, I think, to be able to give it kind of data formatted as a JSON, as a JavaScript object, and it reasoned about it.
Correct,
yeah.
But to give it a summary and to give it that feel of, okay, well then I won't go in front of the pile of boxes, that seems dangerous, I'll walk around the back where there's only one. But to be able to make those decisions is then that conversation of understanding of, well, three-dimensional. Brilliant.
Yeah, exactly. I think the real place we want to get is what Mirek had also hinted at early on in the podcast, where Mirek, you mentioned getting to a higher level of abstraction. So instead of just saying add a box, can you say something like bound this space, like create a boundary so that balls can't roll out of this particular zone? And it's it doesn't get that right very often. It only positions the walls or like boxes that it interprets as walls, maybe 1 out of every 10 times. And it's really interesting. It doesn't really understand solidity either. Sometimes it will just create one large cube around the whole ground plane and say, I did it for you.
Do what you asked. Yep.
Yeah, exactly. But finally, I think one interesting thing about ChatGPT, I ran a test myself. I uploaded an image of a chessboard with 3 pawns that had been moved and asked it to describe the chess opening. And it said, the chess opening depicted in the image is known as the center game, characterized by these moves. And I stumbled across an article the other day that was talking about how strong GPT-4 is as a chess player. And the hypothesis is around its ability to reason about chess moves, which I would argue chess is a form of space, and like games are a form of space in some way. The hypothesis is that it was actually perhaps trained on textual descriptions of chess games. And so it actually sees the notation and was trained against the notation. And so is that sufficient to actually gain enough of an understanding of space at least in that particular setting. I'm not sure. It's certainly an interesting exercise to go through to see what they can do.
Then how do we compare space to place? Helena, it's definitely a concept that comes into things like location intelligence is a phrase that's used a lot. It has the concept of where I am and what can I do. So it obviously needs to come out of a web browser from a web server somewhere and be identified locally to the user. Is that a concept that is also on the rise within models and within, I guess, on-hand devices?
So I do know that, as a geographer, and this is very different, I suppose, to the architecture concept, or even saying that a chess or games are spatial, like in the geographic world. I suppose I don't even know what that would be in the geographic world, but we, I suppose, have a bit of a broader distinction between space and place, whereas like space is a coordinate on the Earth's surface, and so you could quite easily tell a computer spatial stuff. Like that's what the entire premise of GIS is, right? Space is translated into zeros and ones. All the layers you've got there, you can kind of layer everything on top of each other. It's all kind of anchored to a location. And you can analyze stuff about that location. What becomes difficult in GIS is when you're kind of talking about human phenomena, and this is where the place concept comes in, because it's all good and well to that, everything objectively is spatial, but things matter to people differently based on places. People think in terms of places. They don't say, my address is, and then list off the coordinates. They tell you, I live in, and they'll name a suburb or something. And so even suburbs are kind of like, it's a fuzzy delineation, but people think not really in terms of suburbs. They think more granular. They think in terms of neighborhoods and kind of places. And I guess coming back to what you said at the beginning, William, with the architects and designing places that matter to people and where people perceive like a good experience, that links back to that geographic concept of place, because when we're designing a city or, more granular in that case, a building, you kind of want to be thinking about, well, what does this place offer in terms of experience? How do people experience this place? And that's like far more subjective than what GIS can often give us. And so we're moving more towards this placial kind of analysis mode in GIS, and at least in the kind of work I'm doing with quality of life, more in like this GIScience field. We're looking more at places, but it still hasn't really been solved, the fact that you can't neatly put a place into zeros and ones and geocode it into a GIS. Like a place is just inherently a human thing. So I guess that's what I was kind of getting at before, with the concept itself hasn't been understood enough by humans to teach it to a computer. And so the AI, I don't think, can understand a concept that humans haven't understood unless they can have access to far more, of the body of knowledge than any single human or group of humans, or that there just hasn't been enough cross-collaboration between all these schools of thoughts, all these disciplines, all these cultures, all these languages, whereas the AI can probably pull all that together in a lot more coherent way, and maybe we can start to iterate closer to an actual understanding of what makes a place, and what's important in terms of making a place, and then you can start thinking in terms of fuzzy boundaries and whatnot to actually delineate that. But then I guess it's like, is it even important to delineate a place, or do we need to kind of just shift our entire thinking around the questions we're asking and why we're asking them, and kind of, I guess, get more granular and understand that some things are just subjective and on a human level and can't necessarily neatly be projected into a GIS. So I started my PhD with the idea that I would delineate places on a map, but I don't really think that that's going to happen anymore, because I don't actually, from the data I gathered and from the research I did and from the analyses I did and from as far as I got, I kind of got to the place where I understood that it's A, not meaningful, and B, not possible. And so now I'm working more towards understanding place itself rather than trying to map it, if you will. So, and I think LLMs can be important in that regard. So just to circle back to that.
The perils of doing a long-running research project where either your own data reveals some movements or the field catches up with you. Well, look, one and all, thanks so much for that chat. We am looking forward to being involved in your course. We're happy to be your guinea pigs, your test bunnies, anytime at all. Next week, we're going to be talking about a topic of spatial UX. And Mirek, I'm going to dob you in quite a bit here. It's been, I think, well over a year since you released your video on augmented robotality. When was that video released on YouTube?
Oh, that was actually 2 years ago.
2 years, okay.
Yes,
well,
that is quite related.
I'm going to ask for a bit of an update, whether it's a fresh link or at least to describe to us the perils you've gone through in the last 2 years of that version, that line in the sand, and how your definition of spatial interfaces have updated. To everyone else, would love our feedback on both Mirek's work. We can be critics here with scorecards, but more the point, would love to explore all the ways that get us out of these two-dimensional worlds that we're living in. So from me and from all of you, thank you so much for your time today. We'll catch you next week.
If you'd like more news and insights about spatial AI, or have a story or interesting topic you'd like us to cover, reach out to us. Or better yet, come and join the community at Spatial. All the links are in the show notes.